Today's daily code of the day is parsing a Boolean expression number 1106. For this problem, a Boolean expression is an expression that evaluates to either true or false. It can be in one of the following shapes: the character t, which evaluates the true, and the character f, that evaluates the false. The not function, the exclamation point, not function, evaluates the logical not of the inner expression, which means if it's true, the not version is false. If it's false, the not version is true. The and function looks at a large array, basically, and it says that it evaluates the logical and of the inner expression. So if we have true, true, false, it's going to be false. If we have true, 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 it's going to be true. We have the logical or, so that evaluates the logical or of the inner expression. So if it's true or false, it's going to be true. If it's false, false, it's going to be false. And if it's true, true, it's going to be true. So we're given a string expression that represents the Boolean expression. We want to return the evaluation of that expression. So this problem's perfect for a stack. It has parentheses. If we look at the example down here, it has parentheses, it has different operators, it has our characters. And so this is perfect for a stack-based parsing and parenthesis matching. So let's dive right into the code. Our problem is evaluating the Boolean expressions as a string. So our three operators, we have the and, we have the or, and we have the not. So our challenge is to parse it and evaluate it correctly, making sure that we take care of the nested operations first. So as you can see, this is a nested operation because it's within the and operation. Same thing here, we have a nested and operation and a not operation on the outside. So how are we going to solve this problem? We're going to use a stack. And the key idea with the stack is to manage our nested structures. We'll push each character onto the stack until we discover a closing parenthesis. At that point, we can evaluate the sub-expression inside and the parentheses and push the result back onto the stack. So we're basically going to parse it like this. We're going to pick this up, 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 pick this up. That's a closing parenthesis. So we're going to go back to our last parenthesis right there. And the last function is an or, so we're going to or the f. After that, we're going to parse the next. That's our next closing parenthesis, so we can complete this operation. So that's how we're going to use our stack. First thing we're going to do is we're going to call to a helper function, which is going to simply parse our string. So we're going to return, so this helper function is going to return either true or false, so return parse of our expression. By separating this into a helper function, it easily separates each operation into different things. So we don't have a huge chunk of code. We have a bunch of different operations doing things, and it can also help us with recursively solving this problem. So next thing we're going to do is build our parse method. So first thing we're going to do is initiate a stack. And that stack is going to store characters. We could call it a stack, and first thing we have to do is build our parse function. So we're going to have a private, it's going to return a Boolean, and it's called parse. It's going to receive a string s. Now we can build our stack. So we're going to have a stack, characters, we could call it stack, and it's going to be equal to a new stack. So we are going to go through each character in our current string and either push it onto the stack or ignore it. So the things that we're going to ignore are the commas. As you can see here, the commas separate our letters. By ignoring the commas, it simply just shortens our string, makes it easier to parse. So we're going to have for each character C in our string dot to a character array if C is equal to a comma, we can continue. we're going to simply ignore it. There's no reason to include it. Otherwise, if C is not equal to a closing parenthesis, because remember the closing parenthesis is what tells us, all right, now do your operation. We're going to push it onto our stack. Otherwise, if it is a closing parenthesis, this is where we're going to pop everything up until the last parenthesis so we can complete an operation. So we're going to have another stack of characters, and this is going to be our sub expression. And this sub expression is how we're going to evaluate all the characters or whatever else is currently inside our closing parenthesis. So while stack.peak is not equal to an opening parenthesis, we are going to sub expression push whatever's in the other stack's pop. So this is simply taking whatever's currently in the stack and putting it into this new stack so we can evaluate a sub expression before we evaluate further expressions. After that while loop, we can simply stack.pop, and that's just going to remove a opening parentheses. So we didn't include the closing parentheses in the first place, and then once we build our sub expression, we remove the opening parentheses so it doesn't confuse us later on. So the next thing that's going to be in our stack, I can build us a stack real quick so we can visualize this. So here's our stack, and we're going to look at example 3 here, and this is what our stack is seeing. So it's going to receive an exclamation point, then it's going to receive an open parentheses, then it's going to receive the and symbol, and then another open parentheses, and it's going to receive an F, it's going to receive a T, remember we ignore the commas, and then it's going to see a closing parenthesis. Well, after seeing this closing parenthesis, we're going to pop our T, pop our F, and then we pop our open parenthesis, and all that's left next in the stack is the operator. So how do we get this operator to use it? We are going to initiate a character operator, and that's going to be equal to our stack.pop. So now the operator is removed from the top of our stack, and we can do our manipulations with it. So our Boolean result is going to be, and we're going to call to another helper function. So we're going to evaluate our sub expression with our operator. So let's go ahead and quickly finish up our parse function before we get to building this evaluate function. So afterwards, after we're done evaluating this sub expression, we're going to want to push the result back onto our stack. So if evaluate comes back with true, we're going to want to add that to our stack. If it comes back with false, we're going to want to add that to our stack so we can use the next operator to make our manipulations. So we're simply going to take our stack and we're going to push our result. If it is true, we're going to push T. Otherwise, we will push F. That's all this question mark means. So it's going to check, is result, because result is a Boolean. If result is true, is it true? If so, return T. Otherwise, return F. It's as simple as that. So in the case of example 3, we're using the AND operator, and we have false and true. Because they do not match, it's going to return false. So now our stack has an F. Cool. And after, sorry, we'll go back through. So now that we return that, we're going to go back and we're going to see character F and we have another closing parentheses next. So we have that first closing parenthesis, now we have the second closing parenthesis. So our stack sees the closing parenthesis, it says okay, go to the else function. So we're going to create a new sub expression, and while we do not see our opening parenthesis, we continue to pop. So we pop F. Oh, there's our opening parenthesis. We'll get rid of that. Next thing we have is our operator, which is going to be the not symbol. We pop that, and then we get our result again. So we're going to pass our sub expression and our operator. The sub expression is false. The operator is not, so it's going to return true. So our result is true. After we break from this for loop, because we've evaluated the entire expression, we can return our stack.pop and because we want to return a Boolean, we can return it as a Boolean question. So we will return stack.pop is equal to t. If that is true, we will return true, and that will return in our parse. If it's not equal to t, it will return false. In turn, it will return false here, and that will be our solution. So we loop through each character in our input string. Commas are ignored so they don't affect our logic. Every character except for the closing parentheses pushed onto our stack. If we reached a closing parenthesis, that means that we reach the end of our sub expression. Then we pop all the characters to the opening parenthesis. Operators like and, or, and not will always be before the opening parenthesis. And then we evaluate our sub expression. So now let's build our evaluation expression. We're going to have a private Boolean, and it's going to be evaluate. It's going to receive a stack of characters, sub, and it's going to receive a char operator. And so this is going to be just a bunch of if-else statements. We are going to simply evaluate the method based off the operator. So if our OP is equal to our and symbol, while not sub dot is empty, if our sub dot pop is equal to false, we will return false. Because no matter what, if we have an and operator and not every single one of the characters is true, it has to be false. Otherwise, we will return true. Next, we have our OR function. So if our OP is equal to the OR function, while not sub dot is empty, if our sub dot pop is ever equal to t, we can return true. Otherwise, we will return false. Because in the OR function, if you have a t, it returns true. If it has a false and a t, it still returns true. So it's true or false, then it returns true. If it's just false, it'll only return false. And then our last condition is if it's a not operator. So else if OP is equal to not, while not sub dot is empty, if, actually we don't even need a loop here, because with the not operator, it only can ever take in one character. So we will just return our sub dot pop is equal to false. And the reason we do this is if our sub dot pop is equal to false, then that means that our current value is false. However, this is going to return true. If the sub dot pop value is true, or a t, it will return false. So we do the not operator. Otherwise, we return false. If it doesn't hit one of these is if or if else statements, something went wrong, so this should never be reached, but it's there just in case. So let's walk through an example real quick. I have a quick little expression here. So we have and t or ft, not f. So this is all the possible expressions. We have our stack here, and this is how it's going to go. So it's going to receive and, it's going to receive an opening bracket, it's going to receive a t, it's going to receive an or, it's going to receive another opening bracket, ft, and then it sees the closing bracket. So here's going to be our sub expression. This is our OG expression. So in our sub expression, we're now going to get t, f, and it's going to hit another opening bracket. So it's just going to get rid of t and f. Our sub expression is never going to receive the t and the f, or never going to receive the opening bracket. We get rid of that. And then our operator is an or. So we have an operator is equal to or. So t or f, well, we have a t, so it's true. We're going to return true. So we get rid of our sub expression, and it's going to return true. So now we have and opening t, t. So next thing we receive is a not, and then we receive another open, an f, and then a close. So the sub expression gets an f. Our operator becomes a not. So not f, it returns true. Then it's going to receive another closing bracket. So now we could do and ttt, which is obviously going to return true. So if we run this, passes our test cases, and if we submit it, passes all solutions. So this has a time complexity of O of n, where n is the length of our input string, and that's it. So we use stacks to manage our nested parentheses and bit manipulation to evaluate Boolean expression efficiency. So thank you, and follow for more daily LeetCode solutions.